This
somebody
conference
else.
will now be recorded.
So yesterday we were discussing about the basics of data science. Today I wanted to talk about the end-to-end life cycle of data science, something important. So that's the reason we scheduled today's session also. Let me open up my sketchbook. So I generally use the sketchbook for drawing some diagrams and explaining all that things. So let us discuss about life cycle of data science. Let me take a blue color. All right. So in the life cycle of data science, we'll understand about how things have started in the data science life cycle and what are the end-to-end relations or components which are involved in the data science. Now, the first thing in data science, what happened is we had applications which are storing data. So applications which store data typically in databases. Databases. Now, these databases are called as operational data stores or ODS. Okay, the applications will store the data into these databases, and these typical databases are called as operational data stores. So in the initial days, the way the data analysis used to happen is these applications used to store data into the databases and people used to run queries. So the data analysts used to run queries on the databases. And the queries could be very simple as like I would like to find how many kgs of rice are sold in the last month, how many liters of oil sold in the last month, and so on. So it's more like a queries which could be done using the SQL queries, where we try to get the grouping, where we try to get the sum, average, minimum, maximum, like that, where you do the queries on the databases. And typically these queries used to be run on the tables, and whenever these queries are running on these tables, the applications used to get slow. So initial stages where we are trying to run these queries on the SQL tables, people used to have these slower queries on the applications. So whenever we are running the jobs in the back end, the applications used to become slow. So initially, instead of running the queries in the morning time where the applications are running, people then shifted to something called as nightly batch jobs. So what are these nightly batch jobs? Nightly batch jobs used to run in the nights, where in the morning the applications used to run. Just imagine 9 to 5 the applications used to run, the business used to run, and the regular transactions used to happen. And if at all we run the jobs during that time, the applications used to have an impact. So instead of running the jobs between 9 to 5, the jobs used to be run in the night time. So that used to work for quite a few years. They used to have morning applications and then jobs used to run in the night, and they used to get some analysis, and we used to get some forecasting, some important information, and so on. But as the time progressed, what happened is these applications have become global, and with the advancement of internet and all, there was no longer like only morning business. So they were happening 24/7. So with the internet, the applications used to work 24/7, and because the globalization and multiple other countries, the applications were, the business was no more focused on one country. They were focusing on multiple countries, so they have branches across and so on. So if at all I consider the countries like US, Australia, India, Singapore, and so on. So when US was sleeping, the other part of the world was active, like maybe business happening in Australia or Singapore or other parts of the world. So that was how things were working. So what happened is, because the nightly jobs which used to run in the night, that is a day for Australia or Singapore or other geography, they were no longer possible to be run on the same databases. So that's where people created something called as data warehouses. Now, data warehouses, DWH. So data warehouses, what they used to do is they used to do a copy of your database, or basically we call as ETL. The process is called as ETL. What we do is we try to extract the actual data and then you put it into a separate database. So this has provided numerous advantage. One is that we are decoupling the primary operational data stores to a backend warehousing data source. So I can do my analysis at any point in time. I don't have to worry about the throttles or the bottlenecks of your front-end databases. We are not worried about the time zone and all that stuff. So these data warehousings were providing a lot of advantage. So these they used to do a quick copy of the data. They don't used to run huge amount of jobs. Even those copy jobs used to run in the night, so it does not impact any primary business. And the primary advantage of data warehouse is these front-end data sources, they used to have as in data. That means that as of now, whatever the data, real-time data used to be there in the databases. But if at all we want older data, like 1 year back data, 2 years back data, 5 years back data, we don't have that information. And that could be possible in the data warehouses. Now, the data warehouses can save your data for a longer period of time, where you can do a comparative analysis, where you can identify change data capture, and multiple other variants can be done using the data warehousing solutions. But one disadvantage is that the data warehousing solutions are primarily focused on something called as structured data, or the data in a row column format, or mostly like a regular structured format data can be stored. Whenever we are having other kinds of format, for example, say files in terms of log data, logs, files in the form of images, files in the form of sensors, videos. So different kinds of files which are in the form of log data, image data, sensor data, video data, any other kind of feed-based information, clickstream data, and all those things, they are not exactly suited for your data warehousing platforms, and that's the reason people created something called as data lakes. Now, what are these data lakes? Data lakes are more sophisticated storage solutions, which are now capable of storing huge amount of data in terms of logs, images, sensors, videos, and also the regular data warehousing uh, storages. Now, these are typically in cloud providers. So it could be a popular AWS cloud or Azure cloud or GCP, right? This can be any of these cloud providers. They can be any of these cloud providers, and using these data, you would be able to store a lot of information. So we will be able to store a lot of information using this, and you will be able to perform a lot of analysis. But typically, this part of the section is we call it as data engineering. It's called as data engineering. where we are trying to store huge amounts of data, and the data comes from multiple different sources. The data would be coming from different situations and so on. I just want to check if the audio is good. I'm seeing a message that there's no audio or something like that. Can you just quickly respond?
Yeah, audio is good. Siddharth.
Okay, thank you. Thank you. Appreciate. You can go on mute. So, so the data engineering is the area in which we are trying to get all these kind of information from various data sources. It also talks about how do we store, how do we ensure that a lot of transformation is done, storage, coupling, joins, all those things will be part of this area where you do a lot of data engineering, right? Once we get the data into these data lakes, now storage solutions, the next process is where you are trying to do something called as exploratory data analysis. Now that is called as EDA. Now exploratory data analysis is the next process in which we feed this data, whatever is your transformed data, you feed this data to the exploratory data analysis, where you will be doing plenty of operations. For example, you can do transformation, you could do something called as encoding, you could do something called as scaling, missing value, treatment, you could do normalization, you do standardization, multiple other techniques are there. You don't get overwhelmed with all these words, but what we are understanding here is we can also do visualization. I forgot about that, visualization. And all these things, what we generally what we are doing here is we are trying to take the data and then trying to apply some techniques, trying to do some transformation, removing non-value added columns, keeping value added columns, doing some different transformation techniques. If at all the data is in categorical or numerical, trying to convert into one form, trying to get into one space by doing scaling techniques. If there are any missing values, you try to identify the missing values and try to replace the missing values with some meaningful information. Likewise, you would be able to identify patterns of the data. You would be able to identify the relation between the data by doing some visualizations. So there are plenty of techniques in which you are trying to find out meaningful information. The meaningful information, when provided to the machine learning models, they give meaningful output. A simple term is that if you provide garbage to the machine learning models, you will provide garbage output. So when you want to get better predictions, you want to provide better data in good quality. So for doing that, we would be doing this exploratory data analysis, where we'll be applying all these techniques, one or more of these techniques, so that you get best outputs. Got it. So exploratory data analysis is where you are trying to put all these different techniques, and then using those different techniques, you will be able to create a quality data. Once the exploratory data analysis is done, we will be getting into something called as modeling. Now, modeling is where you're applying algorithms. I'll say algos. Okay. So modeling is a technique in which you apply a lot of algorithms like decision trees. You have random forest. you have support vector machine, you have XGBoost, you have different regression models. You have clustering like k-means. And likewise, there will be plenty of models. I have not written all of them like k-nearest neighbors. So these are few of them, but likewise, modeling is a technique in which you're trying to apply a lot of these different kinds of models, and different kinds of models will be applied on your cleaned data to understand the pattern between the data and then create the formula, right? So we will try to create something like a formula or a representation of your data, where that representation will be understanding your patterns of your data, and then that can be used for future predictions. Now, this modeling process is an iterative process. That means that you try to run multiple type of iterations. So I could keep a loop like this. So this is an iterative process, and iterations you try to do some fine tuning on your hyperparameters of your models. Now, hyperparameters are the parameters of the models. While those are tuned, you get better results. So the process is called as hyperparameter tuning. In hyperparameter tuning, what you do is you try to tune your algorithm so that your model becomes better and better, and it will be taking the data and then it will be producing better results. That is called as the hyperparameter tuning. Once you train the model in such a way that you train the model for a longer duration of time, you would get better results. After this, you will be deploying the model onto a cloud. Now, I can take an example of AWS itself. Now, let us take you're deploying on AWS. You deploy the model on the AWS. And when you deploy the model, you create the model as an API so that this model can be linked with an endpoint so that anybody can invoke this model. So I'm just taking example of AWS cloud, but you can take this as any other cloud provider. This stage is what we call as deployment. And deployment would require a lot of technology understanding. You need to understand how do you deploy these things, how do you create these APIs, how do you containerize this entire application so that this entire application can be invoked by a front-end application. Like you have a front-end system. A front-end system is having some input data. Input data is entered, and then you are creating like a submit button or apply button. Just imagine that you have a application which is created for a famous bank, say like HDFC Bank and so on. And what the bank has created is it created an application where people can directly apply loans. Now, as a part of the application, you have to key in a lot of information. What is your age? What is your marital status? What is your current salary? What are your savings? Do you have any other loans? So you need to enter all these information. And once we enter all this information, you press something like submit button. Let me mark it with the red color. So you have this submit button. You press the submit button or apply button. When you apply that, there will be a function which will be invoking the API. So this is invoking the API and passing all these informations like the age, salary, bank balance, and other things. It will be invoking that, and that would be creating your that will be invoking this application, and this model will be returning your output. So the model will be returning, taking all these input parameters, and for the input parameters, it will be returning an output. Imagine if you're doing a classification problem. A classification problem, the output would be, whether it is approved, rejected, withheld, like that. So for that application, whether your loan is approved or not, that is one type. The second one is called as the regression problem, where in regression problem, you will be predicting the numerical value. For example, I want to know how much loan amount can be approved. So the first case will be whether approved or not, and second case will be if it is approved, how much is the loan amount approved. So the regression quantity will predict like 5,20,000 loan is approved. So once the customer keys in all the information and then presses apply, it will go back to the AWS endpoint. It will invoke the model. Instantaneously, it will get the result that the customer is approved for a 5,20,000 loan. So the customer will get a next page that congratulations, you are eligible for applying for the loan. The loan amount will be 5,25,000. Click here to auto disburse, something like that. Right, as you're seeing, this entire system is created in such a way that you are trying to create a model using your past data. So you feed a lot of information related to the loan and other stuff. So the model will be trained on that in the modeling algorithms, and then finally you will deploy that model onto an executable cloud, where you would be creating an endpoint, an API, and so on, so that you can invoke that model, and you will be tagging that with the front end, and the front end could be created with any language. No, just imagine that it is Angular or React or Java or something like that. Okay, I'm not Java or Python. It could be any language. So the front end is created, and that would be invoking this API, which will be serving your output. Right, so this is generally called as inference. This is called as inference. Inference is nothing but where we are trying to do a real-time retrieval of information by invoking the model, and the model will do the prediction, and that could be used for showing back to the application. This linkage is very, very important. Now this is more online based retrieval, real-time based retrieval, so this inference will be used here. Similarly, you can also have a batch process. Now the inference can also be as a batch inference. Now I say batch inference. In the batch inference also you will have the model, and then you will also create an API for the model. But what you see is you will have an input which is fed to the model. Now instead of a real-time data which is being fed to the model, you'll have an input which is fed to the model. Now this one I can call as input.csv. Now this is a CSV file. So the bank got huge amount of applications, and it has collated all the applications of the people who are applying for loan, and then you will take that information as a full CSV file. Let's say 1,000 applications are there. The 1,000 applications, it will be creating a CSV file with all different information, and then it will feed it to the batch model. Now when you are feeding in a batch, internally it will be taking one record at a time, doing the prediction, and then finally creating as an output. And the output would also be a CSV file, maybe, which will have all the customer information. Now it can call as output.csv. This output.csv, what it does is it is having all the customer information, and it is having for every record we're having the prediction ability, like if it is approved or rejected, and if it is approved, how much is the amount approved. That will be provided as one single place. So this is something which a bank person will be running as a job and so on, where you're doing the entire stuff as a batch process, but the batch inference is still invoking the same procedure. This has to be scheduled. Now this is more real time, where people can log into the application, can invoke it, and it is instantaneously invoking the API. But this batch process typically will be scheduled, so you will be scheduling it over night or over weekend. So you would use tools like Jenkins, and this is where your scheduling part, your DevOps thing, all these things comes in picture, where you're scheduling the job, saying that okay, every day at 12 a.m. in the morning there will be a job running which will pick an input.csv, And just remember that input.csv, output.csv, they will also be in the data lake. Here I don't have this link to connect, but just imagine that these two files, typically they will be in the data lake itself. So data will be collected, that input file will be fed to the batch inference model, and through a process in which an automated process will be created, where we will be running this model, and then you will be creating as an output. Now this is called as batch inference. The another application which typically which will be used is called as data visualization. Or data visualization is also a very important thing, where you're trying to explain some of the data. For example, the modeling is done, now you have done your analysis, now you want to explain this as a story to your to your bosses or your managers or your end customers. So you need to understand, like, what are the important columns, what are non-important columns, how are these data points related, how is the relation between your inputs and outputs, or inputs with respect to other kind of inputs. So you would be able to plot all this information in terms of some graphs. So data visualization is a one other important area which will be helping you to do this entire graphing process, where you will be able to visualize your data and you will be able to project some stories. Some of the tools which will be used for data visualizations are Tableau, Power BI. There we will be learning about tools like Matplotlib, Seaborn, and so on. So some of the tools which will be used, so these are some of the tools, but there are a lot of them. It will fill up my entire space. So if I start writing all the tools for every other area, but here what we're trying to understand is, when I want to represent my data, when I want to talk about my data and give some meaningful information. So what I'm talking here is, we are seeing that this particular data is having a clear-cut understanding of what is the pattern which is there, what is the relation between data, and how we can project that relation, so that we can explain some story to the end users. So end users could be your managing team, or it could be your customers, or anybody. So we will be able to explain, like, what is the important columns, what are the non-important columns, so the business can take decision. Business might be giving so much of money for fetching the data from some third parties, and if the data is not at all having any value, and it is not at all providing any inputs, then it is not worthy to spend that money. So you can provide some insights that okay, these are some of the important columns, these are not important columns, and based on that you would be able to plot some visualization. Yeah, got it. So here the second place where we are trying to see, this is data engineering, where you are feeding the data. The second area where you are talking about exploratory data analysis and modeling and all, this is where you will talk about data. I can call it data science. The roles will be data scientist. Here the data engineering, the roles will be cloud engineer, or Hadoop engineer, or data ingestion engineer. So those are all the roles here, where you're trying to do the data ingestion to a specific data lake. But here the roles will be junior data scientist and senior data scientist, who will be responsible for doing exploratory data analysis, doing modeling, doing high parameter tuning, creating deployment models, maybe doing some part of the deployment as well. So those are the different types of roles which will be used here. The role where you will be doing this deployment and creating the APIs, and doing about the Jenkins batch-based inference and all that stuff, these two roles will be done by somebody called as ML engineer. So ML engineer is a person who will be doing the deployment. He or she will be knowing a little bit of modeling. They'll be doing the work, but primary focus will be how do we deploy your model. Mostly understanding about cloud or DevOps, and creating APIs, integrating with the front end systems, creating the required endpoints, doing the testing required for that. So all those things will be done by the ML engineer. The same is the case in the batch process also. The ML engineer would also be responsible for creating the batch jobs, creating the pipelines and all those things will be done by this. A data visualization engineer would be doing the data visualization part, where he or she might use Tableau, Power BI, Matplotlib, Seaborn, any combinations of these tools, where these tools will be helping to provide your entire analysis. Right? So when you're talking from the start till the end, there are different roles at different levels. Now, yesterday there were a couple of questions like, now I am from a data warehousing background, like how do I fit? Now, somebody who is in a data warehousing background, you see that this particular area, so data engineering and coming into the exploratory data analysis, this is a very nice sweet spot. Somebody who is also having a database background, for them also this area is the best fit area. So this area would be helping them to get into the data science part. They will be able to do more of a management of the data transformation and all of that, and slowly navigate into expert data analysis, and then getting into the modeling part of it. Right? So that is the path for somebody of this space. Now, somebody who already have an experience, like say I already did some Java experience, front-end development, or I have developed .NET applications, or having some programming experience, for them the path of machine learning engineer is very good. Like they already have this experience of building applications. Now if they are having experience on the deployment, about the DevOps tools, the languages for creating the APIs and other stuff, like using Flask and Django and other things, and for such kind of people, getting into a machine learning engineer role will be a better start. So they will be able to deploy these applications, they will be able to create the applications. Slowly they will be navigating to the modeling section, where they can use the same language to understand the modeling, and slowly they can become data scientists come machine learning engineers. But the starting point would be this one. So machine learning engineer, somebody who is already having a similar kind of experience, would be this path would be a good one. Now, somebody who has the back-end system engineering experience, like Linux or Unix or jobs based things, scheduling and other stuff, for them this kind of batch-based inference, understanding the DevOps tools which are requiring for that, and then getting into the modeling. So this area would be a good fit for them. There will be somebody who will be doing a BI based tooling. They might have done in data warehouse, business objects, business intelligence related things, doing reports, SSIS, SSRS, and different other tools are there. They might have previous experience. For them, becoming a data visualization engineer in combination with data scientist, this is a deadly tool. They might be using some tools like Tableau or Power BI or any of the proprietary tools of Python, but starting from here and then getting into the modeling and then doing all these things would be a good start. Right? Are you understanding what I'm trying to explain? Right? We are trying to identify from all angles, like all the things which are linked and related. Now, right from the start till the end, we are trying to understand from the very basics of what all things are included. So what are the data ingestions which are happening in terms of databases, logs, images, sensors, and videos? All the data will come into the data lakes. Data lake creation is also a process. For that, one should know probably a combination of technologies like cloud and data engineering and other stuff. Now, once that is done, then you get into the exploratory data analysis. You also do the modeling. You do the deployment, whether it is a inference, online based inference, or it is a batch based inference. And you would also perform some data analysis, visualization, so that you can explain some stories to the end users. Is it clear, guys? Are you able to understand this?
Sitaram, I have one quick thing.
Yes.
Exploratory data analysis will come under a data analyst job.
Exploratory data analysis, yes. The part of that would be part of your data analyst job, where while doing the data analysis, you might have to do some joins, you might have to create some tables or select some sub areas, remove some data, aggregate some data. So not heavily, but definitely some part of that would be part of your data analyst job. So data analyst, as we were discussing yesterday, data analyst is a small level of your data scientist. So you're working on maybe on the tables, working on some of the log files, doing some basic transformations and so on. That will be work of your data analyst. The job role. Okay. There are junior data analyst, senior data analyst, junior data scientist, senior data scientist. Multiple roles are there, but the data analyst will be a part of your exploratory data analysis and some query.
Okay. Can I say the combination of data analyst and machine learning engineer will be the complete data scientist role?
Yes. When you combine those two things, it would be it would become a data scientist role.
Okay. And third thing, like I am clear about that modeling algorithms while deploying into the AWS and coming into from Java and all. So there you are deploying modeling algorithms in some AWS, and from the front end you are hitting that one. You are getting and you are sending the data vice versa. That is clear in the inference case. And second part, like data visualization, where we will deploy these models algorithms, Sitaram? I didn't clear actually because I'm clear about the inference, but here in data visualization, somewhere we need to deploy our modeling algorithms, right?
Yeah. So most of these, when I'm saying modeling, the modeling is all about, I'm talking about the data behind that modeling. So that will be still be in the data lakes. The data visualizations will be connected to the data lakes. The tools will be connected to the data lakes, and those tools would be used for doing the data visualizations. So you would be doing file-based visualizations, or sometimes what they do is they will deploy the output tables. Whenever you do some output analysis in the data modeling, you would deploy the data. So the data which is used for modeling will be deployed in some of tables, and those tables will be linked to the visualization tools, where you can find out relations between columns and rows, and you can use it for grouping, ordering, and other things. You will be able to draw multiple variations of graphs using that. So when I'm saying modeling, the linkage I did it will take the data behind that modeling, and then it will do the graphs with that. Did you
Okay,
understand?
got it. Yeah, got it, Sitaram. And third one, like batch inference is there, right? So here you are giving some input CSV files. So in that case, like first one, like inference case, we are giving the input from any UI like React and all. Data visualization, we are interlinking with the data lakes. There internally they are doing the modeling. This is also clear. Now batch inference case, how we will give that input CSV files? Again, it will take from data lakes, or manually will give that
Yeah.
one?
It will be from the data lake, yes. So when I'm giving the input data, the linkage will be from a centralized place, and that is data lake only. So the batch inference will be triggering where your input output files will be there. So it will pick the input file from the data lake, do the batch inference, create an output file, and that output file will be again put in the data lake itself.
Okay, got it. Then what about here Jenkins?
We have to schedule this entire stuff, right? So I have to say, like, every day 12 a.m. in the morning you have to start this job one, which will take the input.csv from your data lake, run your model, create an output file, and then save that output file into the data lake. That is first job. Then this job, imagine it will take 1 hour. So 12 o'clock to 1 o'clock in the morning, and it means midnight. that this job is running, and 1 o'clock you will have another job. Once the successful of the first job, you will write another job which will take the output CSV. There will be emails of the users of the output CSV, and then it should send an automatic email to the users saying that congratulations, and then it will pick the parameters from the email that how much is the loan amount which is approved. So I'll say congratulations Sitaram, we are glad that you are our best customer. Looking at your past history, we are approving 10,50,000 loan for your this thing. Click on this button to have the dispersal. Something like that, an email will go. Likewise, everybody will get an email, whoever is got approved. So that second process will start at 1 o'clock or 2 o'clock or something like that. So this job linking and one after the other, the entire pipeline creation, all those things have to be automated. You're not going to wake up in the midnight and then running these jobs, right? So that entire pipeline has to be automated so that automatically one after the other things should happen, and your entire system is set. So for that, you would be using Jenkins. So Jenkins is one of the tools. There are a lot of similar automation tools out there in the market, but the most widely used right now is Jenkins for scheduling and running the jobs.
Yeah, thanks, Sitaram. This is very clear now.
Any other questions? So the focus here.
Yes, sir. First of all, this is very informative. Thank you very much. So, from particular resource point.
I'm not sure, Chaitanya. I see there is a cracking voice from your side, I guess. Can you set up your headset or microphone, whatever? Or maybe you can use the chat window to type your question. I'll be answering that. Meanwhile, any other questions?
Hi Sitaram, this is Gauri Shankar. So I'm a MuleSoft developer. Like I usually build REST-based APIs in Mule language. So where do you think I will fit in this life cycle of data science, like as a machine learning engineer or some other thing?
Yeah, it would be machine learning engineer, Gauri Shankar. So in sense, there are a lot of job opportunities or roles there, but what I would recommend people is getting an entry to this path would be an easier stuff, because like what is happening here, how do you do integrations. MuleSoft integration engineer would be having an understanding of how do you create APIs, how do we invoke it from multiple endpoints and so on. So this is an easy entry point, and you understand this path, and then when you go to the modeling, you slowly understand how do you build algorithms, and then slowly you can navigate to the other areas, right? So the entries would be easier, and whenever many times what happens is people will be working on in some of the service companies or maybe product companies or different other companies where they get opportunities and they would like to navigate into that area, right? And an easy way of navigation is to identify the right area which they can easily penetrate to, and then once they get settled there, they can expand their horizons on understanding the other connecting things and slowly expanding to the other areas. So my focus here is to give that kind of a clue that where does everybody can go through and get their path. So yeah, as you rightly said, that path would be a best for you, where you can slowly navigate into the area, and once you get that experience, right, now then you can yourself as a data scientist or junior senior data scientist depending on your experience level, and then pitch for other jobs.
Okay, yeah. Thank you, Sitaram.
Hi, Sitaram. This is Vamsi.
Yeah.
So I'm a data warehouse developer. So like you mentioned yesterday, I would fit in the place where the data ingestion framework and the first part of the pictures that you've drawn, like data engineering section. So by taking up this course, will it help me to have an understanding. I know I will have an understanding on the ML and AI part, but as a data warehouse developer, as you mentioned, there's not much of those algorithm learnings and everything in the first half. Like it's just related to AWS, GCP, and pushing the data into the data lakes. So,
Correct.
where do you think it will probably be helpful? Will it help me in terms of getting to like a machine learning engineer or a data scientist, or still I
Yeah.
could stay in the data engineering space and gain some knowledge on?
There are different thought processes there. So if you are looking for a bigger corporate this thing, you would see that there are clear demarcations about what a data engineering team will do, what a data warehousing team will do, what data scientist team will do, data science team will be there. So there will be a thin line between these two areas, and probably they will work as a part of one team. And I have seen many people who are jumping from the data warehousing to the data science pipeline, also jumping till the deployment and all. Many people do not have the front end experience, like how do we create APIs, how do we deploy them, and maybe on the language part, most of my known contacts have experience in creation of mappings, database queries, store procedures, and that kind of a stuff. So what they do is they really shift to this exploratory data analysis when they get a chance. Mostly they know like how things are, how data is ingested, how other types of data is ingested, how do we do mappings and transformations and so on. So easy entry would be getting into exploratory data analysis, where they'll be doing advanced transformations, treating the missing values, cleaning the data. So there is a ton of work here in the data science area where you need to clean the data to a maximum extent so that you can apply them to the model. And nowadays what we are seeing is we are having all these cloud providers which are giving plug and play modeling tools. Now I don't have to be a very great researcher to create an algorithm right from scratch. So what I see is people who are from these data warehousing professional who are having some understanding of Azure or AWS, they use some of these tools like plug and play tools, where they can create quick and easy models where they don't have to do a lot of programming, but they know like what model is what, why we use which model, and so on. And then they will be creating some end-to-end APIs, and somebody else like a front-end person would be doing the integration and so on. So I would say that entry into this exploratory data analysis would be a right path for a data warehousing professional. People can also settle here, but it would be stagnant. If at all you expand yourself, it would be better, right? So that is my thought.
Yeah, thank you, Sitaram.
Sitaram, one question. Here are different
Mhm.
sections like a data scientist, data analyst, and ML engineer. My question is, for becoming a data scientist, what are the prerequisites? Like any particular language, get to know,
The
database, reporting tool, so and any front-end tool. That kind, any minimum basics is required.
The language which I would prefer is Python. You need to know Python, because the end-to-end, whatever we are seeing in this particular diagram, end-to-end can be handled with Python. We can create APIs with Python. We can do exploratory data analysis. We can create modeling. We can create batch inference, scheduling the jobs, moving of the data. Everything can be done using Python. So that's the reason our course is also primarily focused on Python. And so there is a question like what all things will be covered in the course. We will be covering right from the data ingestion till the end, right? We will be covering how to do deployment, how to do AWS deployments, how to do inferences, how do you do data visualizations using Matplotlib and C1. I will not be covering on Tableau and Power BI, but we would be covering on Matplotlib and C1, which are Python tools. And we would also be covering about batch inference. How do you do feeding of the input data? We will be covering the DevOps angle, where we'll be learning about Jenkins. How do you create containers and deploy the containers of the models? We'll be creating end-to-end applications which could be, invoked like a front-end application invoking a back-end model, giving back the results, and so on. Primary, I would say 50-60% of the course would be on exploratory data analysis, modeling. In modeling itself, we will be having multiple variants. We'll be having supervised machine learning, unsupervised machine learning, deep learning, natural language processing, and so on. But we would also cover these other areas. And as I was saying yesterday, cloud computing and DevOps is a deadly combination along with data science. If we have that combination, you would be deployable at any project.
Thank you. Thank you very much.
Right. So Chaitanya, did that answer the question? So I was kind of answering your question also.
Yes, Sitaram, thank you.
So there is a question that explain the difference between standardization and normalization. No, we are very initial stage to understand all these things. Definitely, when we get in deeper, I will be explaining the different algorithmic process which are different between all these terms. So we will discuss about that later. I think for this discussion, I think it is very early, because I have to give a lot of background about why we are doing it and all. So then it would take more time than expected. All right.
Hi, Sitaram. This is Satya Dodda.
Yes.
I'm working as a ETL architect, and almost 15 years I'm working in this area. So if I switch to this data science, do I have to compromise initially salary, or do you think
you are you already working as an architect? So I would focus saying that you become a data science architect or data architect, or in those areas you should focus. And believe me, the salaries are competitive. I'm not sure where you are, whether you are in India or US.
US? Right now I'm in US.
Right.
Yeah, ETL architect. Yeah.
US, I'm seeing that there are competitive salaries definitely for a data science architect who knows. So they should know this end-to-end cycle, like what is happening, what model should be used, how should be used, what data should be captured, what additional data should be fed in, how the processing times will be, and pre-processing, tuning, hyperparameter, all those things will be under the control of a data science architect. You can tell that person is a little above data scientist, who would be overseeing all these things. Maybe data scientist will be doing individual portions, so he or she will be doing maybe creating a model and so on. But a data science architect would be entirely designing the pipelines. So that jobs definitely have good understanding, because you already have a data warehousing background, right?
Yeah,
that is a very good prerequisite, right? So because data warehousing is nothing like, it's the same thing, old wine. So the data science is like a old wine in a new bottle. So where data warehousing is the actually cuts, right? Where we are doing a lot of analysis, but now that is expanded to a little bigger scale, with a lot of newer data points and so on. But if you practically see, all the businesses are still having structured data only, but they're trying to combine multiple other data points and then trying to make it seem like unstructured or very complicated. But most of the businesses are still having data in their Oracle tables or DB2 or whatever, and then still applying the same techniques. So that should be your focus area. I think it was Satya, right?
Yeah. Thank you, Sita.
All right.
Yeah, hi Sitaram. Yeah, actually
Yes.
I'm from electronics background and I want to switch my career since there is not much growth in my profile. So one of my friends has recommended me to attend this demo course of you. So I do not have any programming background. So still can I learn something and I can switch my career into this profile? Is there any chance?
You have some experience, Shrikant. You have some experience of what
In
development
electronics,
in
not in the
electronics.
software side. Yeah.
So I think you should focus on areas where there are a lot of these electronic companies also. Electronic in sense software chip manufacturing companies like Qualcomm, Xilinx, and other.
Okay.
Let me mute. Would you mind muting?
Yeah, sure.
There is a background noise. Okay. So I would say that first focus on the language part. If you really wanted to get into this, this would be a very technical course for you. Honestly, believe me, if I say that, everybody can come and, please come and join, you will be the next big hero and all, I will be fooling people. I really don't want to do that. So what I would really suggest you is to get firstly on the language part. So you might have to target on one language, preferably Python, because Python is used everywhere. In fact, it's also connected in the electronics industry and so on. A lot of similar electronics company, if you want to come into the software part, you need to focus on how this language is being used for electronic chip manufacturing or material designing and so on. If you focus, there are a lot of startups who are working in the space of IoT and things like that, like Zigbee controllers, SCADA controllers, or LoRa framework, and the different other communication protocol frameworks are there, which requires software engineers and who has knowledge of electronics. So my sincere suggestion would be trying to work on that area where basically you need to focus on a language part, and once you get into that, then you can expand yourself into the data science or related things. Definitely they are doing a lot of work in that space. For example, IoT and data science, there is a very clear merger, and a lot of work is happening in that space. And in the coming years, I see a lot of applications coming into that space also. So my sincere advice would be do that rather than this entire data science and all of that would be for somebody who's already working in software and who already knows like how the data works, how the data can be handled, either building applications or handling data. For someone in that space, definitely it would be advantageous, right? If you really wanted to do the course, definitely I would recommend, but my sincere advice would be focusing on something, because you are investing not only your money but your time, which is very valuable. Time and effort is very valuable, and I don't want that to be wasted. So your primary focus, first one, would be learning the language Python, and then starting with some of the things. Identify where are your electronic things could be helpful, so that identifying companies, startups, and things like who are focusing on these professionals, and definitely there are a lot of them, and believe me, so your focus should be that.
Okay. Yeah, thank you.
And if you like listening to me, definitely you can join the course and learn. Definitely you will be learning very much more than whatever you already know right now. But my advice would be getting a Python course.
Yeah, sure.
All right, any other questions regarding the course or any of the content or what we are going to cover and how we are going to cover? I think the course curriculum is already shared with you. I think there's a message which is floating out where it has a Google document about the course curriculum and all. So please go through that. We have at least 20 projects we'll be doing throughout the course, and importantly, I want to cover this topic, and that's the reason I have asked to schedule on Sunday. I'm really apologizing for that, but this is very important to understand, like how this entire life cycle works out. and to clarify some of your questions and doubts, whether it is good for you or not good for you, what will be covered and to what depth you would require to be doing any coding or understanding. So this is a 3-month course. I iterate. It will be a daily course every day on the weekdays, Indian Standard Time, from 6 o'clock to 7 o'clock, where we will be spending 1 hour every day. And it is expected that you, apart from this 1 hour every day, you at least spend 3 to 5 hours over the weekend or maybe on the week, so that you can refresh your topics. We would be also doing some assignments, so it will be like a homework mode. You have to perform your homework and do some assignments and complete that. It is expected, so you're going back to the school. And we'll be also having some quizzes which will test your knowledge and so on once in a while, where you can compete and you get some marks and so on. And we will be doing these 20 projects. Those are mini projects throughout the course, and in the end of the course we would be doing capstone projects, which will be like end-to-end applications which we are developing, so that we can deploy it on like AWS cloud and so on, so that we will be able to showcase the projects to potential employers and so on. So the focus of this course would be getting you wherever you want, whether you want to shift jobs or getting more knowledge or getting employable or making more sound confident in the space of data and all. So that is the primary focus, and we will be applying that using a project-based learning. All right. Any other
Last
questions?
question. After the course, are you any certification is there available to do, or so? What is your input on that?
You're asking whether you get a certification from after the course, or you are asking whether you want to write a certification?
So actually, I don't know what kind of certifications to do for this that after completion of this course. So what are the certifications we have to do? And your course as per as per the course, as per the certification, your course.
Right. See, so I'll answer 2 questions. So once you complete the course, you would get a course completion certificate. Now that is like that you have done this course. That is one part. The second one is you can write some external certifications, the certifications provided by some famous vendors. For example, you have certifications by AWS, Google, Azure, and so on. ML engineer, data science certifications are there. Also certifications from other vendors like IBM. We have these certifications. But what I would focus is more on project-oriented learning, where we are trying to create ourselves deployable in terms of projects rather than clearing certifications, spending more money for that. And definitely the trend is changing. In the olden days, people used to ask, did you do this certification, that certification and all? But nowadays, people also see that there are all dumps available and people are passing those certifications. So primary focus is on building the projects rather than on the certifications. When I interview people, I also look at that angle rather than they say that, sir, I have passed so-and-so certification. So, my take on that would be that. But nevertheless, if you wish to do any certifications, this course would be more than enough, because we'll be spending a 3-month duration of entire end-to-end learning. A lot of internal topics would be covered. So you might have to be spending a little 1 more month maybe for preparing that certification. And if you're looking at one of the certifications, there will be a slight flavor difference. Primary concepts would be same. We would be talking about the algorithms, the deployments, and other things. But there will be a slight flavor depending upon which vendor certification you're doing. Say AWS will include their own products, Azure might have their own products, but the base 60-70% of the questions would be asking on the ML and data science and deep learning related to that. Did I answer that?
Yeah, thank you.
Hi Sitaram, this is Jayant. I have a quick question. So just
Yeah.
going through your projects and you're saying like we're going to build those chatbots and everything, right? So are we going to use some kind of AWS models and or cloud models and build those chatbots, or we going to do it from scratch?
We are learning to build it from scratch, but we will also learn like what are the pros and cons of using over the counter tools, and those all things comparisons we'll be doing, but the learning will be doing it building from scratch. Once we know from the scratch, then now it would become very easy to plug and play any of the other available tools. So the focus is on understanding how to build it from scratch. We will be using deep learning for that, a specific model called as recurrent neural networks, which will help us build chatbots of any size of any requirement.
Okay, thank you. And continue to that question, like, okay, if we are able to do those from scratch and everything, and the people who are not from development background, so will they be able to fit in, will they be like, okay, in a good pace to pick up as a ML engineer space and everything? Because building it from scratch means you're just doing the complete development, right? So will they be able to say like, okay, yeah, I have some kind of development projects which I can do, and I can take the machine learning engineer starting as a startup position or something like that?
Yeah, because whatever the development which I'm saying, that was almost happening at the fag end of the course. By the time if they do the entire course, right, this is a 3-month journey. By the time they will be comfortable, we'll be starting from a very basics. We'll start from math for data science, then we get into the programming, Python part of it, building basic models, then slowly stepping up to a little complicated ones. The chatbots are into the complicated section of deep learning and so on. So by the time they come there, definitely they will be able to understand.
Yeah, thank you.
Hi, Siddharam. I just wanted to know about the reinforcement algorithm. Like while you are explaining about the self-driving car, you said like by using reinforcement algorithm, we will do the self-driving cars and all, right? Like there, it will provide the feedback mechanism to the models. So can you explain in brief?
You want to, instance, you want to know more about that, the reinforcement learning?
Yeah, just I wanted to clarify, like I'm assuming in reinforcement learning case, for example, in the existing model, we don't have the U-turn case, like how to take the U-turn case. That U-turn case, it doesn't exist in the existing model or algorithm, whatever it may be. Then how it will be like, it will give the feedback mechanism to that model automatically. Then how it will be model again finalize that this U-turn feature.
Yeah, so the way it works is when the U-turn is not there, the first time it will fail. The model will fail. The car will try to go straight and it will fail. Like once the failing is done, the feedback, what happens is the action is a safe drive, which is within the boundaries of yellow lines, but that has crossed, right? So the car will observe that, and that gets as a feedback. Okay, so it's a feedback of a negative feedback. When the feedback is crossing your specified boundaries and speed and other things, all those things are captured, and those are acted as a feedback. Now, the first time it is failing. The next time, even whenever it is not learning the U-turn, next time it will still try to go straight, but whenever it is failing that yellow line, crossing the yellow line, it will try to take a corrective action. So as if like it is taking first time a ghat road, right, going to some hill station or say Tirupati or something. So it's taking the ghat road for the first time. It will face a lot of problems. So it will try to slowly learn, and the learning in sense, it is providing the feedback, whether it is cutting lines and crossing the roads and so on. And then after it does this certain learning, so we have cost functions which will optimized for corrective driving. So when we take your output of your reinforcement learning models, we derive multiple cost functions which will be optimized for different actions. For example, cutting lines, overtaking, speeding up, speeding down, sudden braking. So all these different cost functions have to be solved. Now, once we solve those problems, we are trying to minimize those errors like cutting lines or overspeeding, underspeeding, and that will give feedbacks at every point in time to the model so that it will take appropriate action. Right? For example, it is speeding up, it will be providing feedback so that the action would be slowing down. So there are corresponding models which will be built, which will provide respective actions, and that would be taken forward. In fact, reinforcement learning itself is a huge area which is combined of multiple things, like supervised machine learning will be there, feedback loop mechanism will be there, extended cost functions will be there, and their minimization techniques, identifying gradients of that. So all those things will be combined together, and then we'll be building better systems. Got it?
The developer solve the problems, or the problems will be solved by the academic level, like existing model, they will add all the feedbacks and all, or developer going to add the features?
No, it is a complete project, right? So developer will be either adding features or creating corrective actions, or you would be having business folks who would be identifying multiple variant features, changing in the differences you would be identifying, and then based on that, new features would be added on the fly.
Okay, got it.
All right, so any other questions? I think let me check the time. Yeah, a little over 1 hour 15-20 minutes. So any questions? I will be happy to answer them, or else we can close the class here. I hope you got a very good understanding of whatever we are going to discuss. So tomorrow 6 a.m. to 7 a.m. would be the actual batch starting. I'll be talking about different mathematical concepts which are required. So the base for your data science is mathematics. It's a very under thought subject, but it is very important. So we will discuss about those topics in the next session. All right.
Thank you, Sitaram.
Thank you very much, and have a nice day and have a nice weekend. Please stay safe, and if you like this